Welcome to this demo video for a new circuit that's been released on the underscores label called the lateral LED controller, which is a hardware network interface for addressable LED installations. This is actually part of a series of open source tools for video installation work, which I've been releasing. The last one you may have seen was to do with mapping software for TV wall installations. This controller is part of making addressable LED installations. There's also a software component to this, which will be a separate video. Basically, what this does is it takes artnet, which is a DMX protocol over the network, to send the lighting information into the controller, and then the controller converts it to the specific LED strip protocol that's used to drive those LEDs. So yeah, in this video I'm just going to talk a little bit about LED installations and how they work, and then I'll show you a demonstration of how to set this controller up for a practice installation. Here we can see the inputs and outputs of the controller. So yeah, it comes in this PCB sandwich style enclosure. You power it here. You can send it anything from 5 to 12 volts, and you want to power this with the same strip that you're using for your LEDs, same power source. Then you send the artnet in over Ethernet here. This is a RJ45 jack to the microcontroller. The data out, this is the wiring that goes to the LED strips themselves. You have these little terminal blocks which you can put the wires in. There's also the option to output the data lines over 45. This is can be useful if you want to send multiple data lines through one cable over a long run. Then on this side, bootloader's not quite correct. This should say serial. This is where you can upload new firmware onto the controller, and then there's a controller reset button on the side, and next to that is a network connect LED, which you will see lights up when there's a connection made. So this is an example of a addressable LED strip, and each one of these little squares is a RGB LED. We can control the levels of each individual LED, its red, green, and blue channel. So this is the GitHub page for the controller, so you can find all information about how to get the circuit, see the schematic, the Gerber files, all that stuff is on here as well. These examples come from a club night called Lateral Movement, which I was a part of, where we'd put on these events and we'd use addressable LED installations for a couple of them. So this is the inspiration for this project. You can see here, in this case, we're using artnet LED mapper, which is some software runs on the computer. Then we output over a Ethernet cable the artnet, the lighting information, which goes into the controller, which is what we're talking about now. Then the controller outputs the different LED strip protocols to the LEDs, and then we have a power supply which is powering the strips and also the controller. But yeah, you don't have to use the software I'm talking about. There's also programs like Touch Designer and Resolute. These are the main two kind of families of addressable LEDs. So this is what the controller supports, but it is possible to add support for more with firmware updates. So the first type is called WS281X. This is also called the Adafruit version of this strip is called the NeoPixels, and it does come in a few different types. Like you can see here, the 2813 is the 5-volt version, and the 2815 is the 12-volt version. So this is what we ended up using for our version of this installation. They are very cheap, so you can get about you can get a meter with 60 of these for around $5. The way that they work is the data which is sent to them is over a single wire, but it is quite a slow protocol. So this means that on a single wire you can output to around about 240 LEDs before the refresh rate of them drops below 30 frames per second. However, we can get around this by outputting basically multiple data lines in parallel. So the easiest way to understand this is this little diagram here. You can see that on the controller it outputs, there's up to 8 parallel data outputs, and you just connect one line to the start of each of the different data lines which you want to control. So the other option for addressable LED strip is this APA 102 style strip. So these are the Adafruit version is called a dot star. Sometimes also you see it called a SK9822. So these strips cost more, about twice as much for the same amount of LEDs per meter. And for these ones, they send the data over 2 wires. So the first is the data line, and the second is the clock line. But this protocol is extremely fast. So if you're using these kind of strips, there's no need to use the parallel outputs. You can chain as many as you like up to the 2000 limit, or like soft limit that we have on this controller, or from the 2 lines, just connecting the ends to the strips to go wherever you like. So yeah, these also claim to draw less power. And yeah, you're also going to need a power supply that's going to supply the power to the LEDs. So yeah, we ended up using like a switching power supply, kind of like this. They're pretty cheap, and you can get them in lots of different power outputs. So you just need to calculate how much power you need for the number of LEDs that you're going to be controlling, and then also the type of LED that you're using will determine the voltage, and then you just buy a supply which handles that. And yeah, then another thing to think about is light diffusers. So usually you want some kind of cover over top of the strip so that the change in light is kind of smooth rather than like individual pixels, which is quite can be a bit jarring. There's lots of information about light diffusion for LED online. So I'm not going to talk about this. This is very specific to your use case. But yeah, I also want to talk a little bit about the wiring and the connectors. So again, this is quite specific to your use case, and people have quite strong opinions on how to wire things and plug them together and so on. I wanted to make it as easy as possible to set the installation up and pack it down, and I wanted to minimize the amount of cables that need to be used. Just regular wire into this terminals and screw it down, and that will make a connection. And then since they're pluggable, you can quite easily just unplug the whole thing out and plug it in when you're taking it down. Then yeah, as I mentioned, you also can send multiple data lines through Cat5 cables. So yeah, each one of these twisted pairs will take a different line twisted with ground, and then at the other end you can separate this into the different LED strips. I think it's better to separate your power lines from your data lines. So like if you look at the LED strips the way they come with all of the power and the ground and the data all together on one of these JST connectors. But for our installation we sent power separately, and so I think that these screw terminal barrel jacks are quite a good way to send power, because you can still screw in your wire into it, but just make sure that you're not going to accidentally plug it in the wrong way. Once it's screwed in, like the ground and the live wire will always be where you expect it to be, and you're not going to plug your power into your data or something like that. I feel like having the power separate on a separate kind of connector, which we know is used for power, just makes a bit more sense. But this is totally up to you. But yeah, also, if we want to avoid too much like unsoldering or like soldering onto the strips themselves, I did imagine these custom adapter boards that can be used to convert the different kind of formats for sending wires around. I couldn't find the PCBs to show you the physical ones, but here's just like a render with some kind of examples of how they could be used. So one of these boards, the JST adapter, it plugs, one side of it plugs directly into the LED strip with the JST plug that comes with it, and the other side breaks that out into barrel jack for the power, and then a terminal for the data, sending the data line from the controller into the adapter, and then plugging the strip into there. The other one is for if you wanted to use the Cat5 cables to send the multiple data lines in one go, then you could do it like this, sending multiple lines out to one of these little RJ45 adapters, and then from that you break out the different ones to the different strip. Okay, so the first thing we need to do is power on the controller. So we can do that just by plugging in this case, a 5-volt supply into the power input. You can't see it here, but I can see that the small red LED inside here has come on, so that indicates we have got power. To connect to a local Wi-Fi access point, which was created by the controller. So if I go to my Wi-Fi settings on my computer, I'm looking for a Wi-Fi a access point that's called LEDs. And now the password to this is LEDs. So LEDS. And you put that in and you connect to that network. Then we can get to the settings by typing in LEDs.local. And this will take us to the web server that's been created by the controller. So here we are on the lateral LED controller settings. So here you will see at the top we have the network settings. So this is how we connect to the controller to send it the artnet information, and then below that we have the LED settings. So this is how our installation is set up. So you see here we can select the type of LED protocol, whether we're using the APA 102. This one, remember, only requires a single, well, two lines coming out, but then all of them chain together from there. Or if we take the WS28151, then we need to tell it how many parallel outputs or data lines are we using, and then how many LEDs are on each line. So yeah, then below that we can tell it basically how long to wait until it updates the frame. So this kind of sets the frames per second, and also we can tell it to update on ArtSync, which is a special packet in the ArtNet protocol which indicates the end of a frame, which can be useful for syncing it up. So let's go back to the network settings. We don't need to know too much about networking for this to work, but yeah, there is a little bit of configuration to do here, to do with the IPs and the gateway and stuff like that. So yeah, we can connect to it either as we are now, so access point, which is it creates a network and we connect to it. We can also tell it to connect to a existing network, so we can put in the name and the password of the Wi-Fi in my studio, and then we can talk to it through the router here. But the main thing this was designed for is connecting to it over Ethernet, because if you're planning to use this in like a nightclub setting, you don't want to be sending information over the air. You want to have a wired connection where you know it's going to be stable. Probably the safest thing to do is to just assign the IP here, and I think we can just use this default that's in here. What we're going to hope is that if we set up our Ethernet correctly, we should see this light come back on once we've connected the Ethernet input. So let's go back to the screen sharing, and I'll show you my network settings. So I'm going to use this wired connection, and then I'm going to manually set the IP here, and we can see here I've already pre-entered the values that we want. So the subnet mask is the same, 255.255.0, and then we're going to use the gateway which we set on the controller, and we're going to set that to be both our gateway and our address. So our computer's acting kind of as the router in this situation, and this is going to be accessible via the IP that we set to it. So I'm going to plug the other side of this Ethernet cable into the controller, and we should see, hopefully, it will establish a connection. So there we go. Straight away, that light comes on, which means we're connected. So that's a good sign. So in the terminal, I'm typing ping and then the IP of the controller, 192.168.5.100, and this will tell us that there's something connected there, and it's returning our ping. So that's a good sign. And then also, if we put that IP of the controller into our browser like this, it takes us back to the settings page. Yeah, so led.local, this is this should resolve to the IP of the controller, but if it doesn't, then you can use the IP itself. Another thing which I want to show you is how to do a factory reset of the settings on here. So it's possible that you might get this controller into a state where you can't connect back to the settings. So let's say, for example, in the settings we set it so that it was supposed to auto assign an IP, but then when we plugged it into the computer, it wasn't auto assigning, and the led.local wasn't resolving to anything, so we just couldn't get into there. So the way to get around this is there's a way to hard reset on the controller. So you can see here we've got this controller reset button, and if we push that, it will just do a reboot of it. So I'll push it once, you'll see the light should go off while it's rebooting, and then when it comes back up, it will reconnect to the network, same as before, and the light comes back on. So this remembers all the information that was in there, and every time you if you unplug it and you boot it up, it will remember the IP scene and everything. But if you want it to forget everything and start from scratch, what you need to do is hold this down for approximately 5 seconds. 2, 3, 4, 5. And then release it. Now you see the lights flashing. That means it's preparing to do a hard wipe of all of the stored information. If you don't want this, unplug it now and it still will save all your information. But if you want it to hard reset, press it again in this mode, and now it's doing a factory restore. So now, even though we've got the Ethernet plugged in, if we want to connect to it, we're going to have to go into our Wi-Fi and find that LEDs network, and then type in LEDs, and then that will take us into it again. Okay, so now you can see the very janky practice installation which I have made here. So it's a piece of cardboard with 8 LED strips laid vertically across it. So we're using the WS2815 strips. These were left over from the installation that we built. And there's 20 LEDs per strip. And then you can't see it too well, but up here in this corner, each of the different strips is being wired into a different parallel output from which will plug into the controller. So we're going to use all 8 data outputs, and each one is going to have 20 LEDs on it. So we can set this information in the controller settings. Here we go, active data lines is 8, and then each one is going to have 20 LEDs on it. So it's important that you tell the controller exactly how many lines that you're using and how many LEDs there are on each one. Now let's take the controller off of my desk and install it over there with the LEDs. Okay, so I've plugged the 2 data lines terminal blocks into the controller, and now let's bring over the Ethernet connection which we've just set up, and finally we're going to power it. So we're taking a 12 volt power plug, and we're going to split this, so one's going into the controller and the other's going into the LEDs into the controller. This one. And now hopefully the network should connect. Yep, blue light comes on, which means we're connected to the network. So I'm using the ArtNet LED mapper, and there'll be another video where I set this up for this particular installation. But for now, we can see that the video is being piped in from the browser. I'm using Hydra in my browser to generate this slowly moving gradient, and that is then being mapped via the map that we've set up in the program, which is where we define each of the LED strips and which color should be which, and that is being sent out over the Ethernet cable via ArtNet to the controller. The controller is receiving that and then outputting the information. And maybe we'll make these oscillations a bit more. There's another pattern. Maybe that's a bit too much detail for this very low res thing. That's really all that I have to show for this video. Yeah, hopefully if more people are interested in doing this kind of art, we can try and make this controller better for everyone in the future too.